If we increase the temperature, then the substances that are present inside our conical flask will collide with each other at a faster rate. So at an increased temperature, the redox reaction will take place at a higher rate. Okay. So when we increase the temperature, your hydrogen value will be very less because already at 70 degrees Celsius the reaction might be completed. But whereas at room temperature, if you do not keep your conical flask in the water bath, if you did not keep the conical flask, then the hydrogen value will decrease. Okay. So the case study is about the standardization of 0.1 normality potassium permanganate at 70 degrees Celsius versus room temperature. So here the primary standard is 0.1 normality oxalic acid. We are going to standardize the solution of 0.1 normality potassium permanganate using the primary standard 0.1 normality oxalic acid because it is a pure compound. And the standard solution, the solution we are going to titrate is 0.1 normality of potassium permanganate. So normally in redox titration, we need one oxidizing agent and a reducing agent. Here the oxidizing agent is of course potassium permanganate and the reducing agent is oxalic acid. As we are going to standardize an oxidizing agent, we need a reducing agent as the titrate. Okay. So when we titrate, what will happen is the potassium permanganate, that is the oxidizing agent, will oxidize the oxalic acid, that is C2O4. Okay, but itself will get reduced into Mn2 plus ions. But whereas the oxalic acid, which is specifically a reducing agent, will reduce the potassium permanganate, but itself it will be oxidized into carbon dioxide. Okay. So now this reaction will take place only at some higher temperature than normal room temperature because only at 70 degrees Celsius the reaction will take place in a faster rate and the color of potassium permanganate from urine will be reduced. Here we will not be using any indicator because potassium permanganate itself is a self-indicator. So we will not be using any special indicators. How will we identify the endpoint is with the help of potassium permanganate, which is of course a colorless solution. It is a purple color solution. The purple color of the solution will be reduced initially because we have a reducing agent. And at the end point, after all the oxalic acid is getting reacted with potassium permanganate, at the end point there will not be any more oxalic acid present in our conical flask. So there will not be any reduction of coloring potassium permanganate at the end point. So at the end point we will get a pale permanent pink color. Okay. So now we are going to see how the temperature will affect the titrant value. Normally what will happen if we do this experiment in room temperature and what will happen if we do this experiment at 70 degrees Celsius. Okay. So let's begin the experiment. So for doing this experiment we need, of course we need a conical flask, urine, then measuring cylinders and standard flask for preparing the solutions. And we have solutions of 0.1 normality oxalic acid and 0.1 normality potassium permanganate. And the reaction as it takes place in the presence of some acids, we need dilute H2SO4 also. We have to prepare a conical flask using oxalic acid, dilute sulfuric acid, and we are going to heat it at 70 degrees Celsius initially for titration. And after we are getting a titrating value, we are going to repeat the experiment at room temperature.
After heating the solution at 70 degrees Celsius. The titrant value is 17.5.
At a room temperature, titrant value is 19.6.